You know, we throw the word quality around all the time, right? Quality products, quality service, quality everything. But what does that word actually mean when you're talking about business and engineering? Well, let's get into it.
I mean, just look at this. You don't need a definition to know that this is a high-quality experience. It's totally intuitive. We've all got this built-in radar for what feels premium, what works the way it's supposed to, and what just feels right.
But here's the thing. That gut feeling, it's not enough to build a business on. Come on, if you're making thousands of cars or serving millions of people, you can't just rely on a good feeling. You need a real system. So the big question is, how do you take that intuitive sense of what's good and turn it into something you can actually define, measure, and most importantly, repeat over and over again?
Okay, so let's try to pin this down. To actually build quality into something, you first have to agree on what it is. We've got to get beyond that feeling and create a solid foundation.
And here it is, the heart of it all. Quality isn't just about how well made something is on its own. It's always about the customer. It's a measure of excellence, sure, but it's completely tied to whether you met, or even better, went beyond what your customer was hoping for.
And of course, the experts have their own more precise takes. The American Society for Quality, or ASQ, looks at it from two sides. Does it do what you need it to do, and is it free of any problems? The big one, ISO 9000, is all about fulfilling a specific set of requirements. And the legendary quality guru Philip Crosby, he put it in the simplest terms. It's just conformance to specifications. Did you build exactly what the blueprint said?
Now check this out. We can boil all that thinking down into this one super powerful little formula. Quality equals performance divided by expectation. Think about it. If your product performs exactly how the customer expected, Q equals 1. But if it performs better than they expected, Q is greater than 1, and boom, you've got a seriously happy customer. It's just a beautifully simple way to frame the whole thing.
So we've got a definition, we've even got a formula, but here's where it gets a little tricky. That formula depends on one key word, expectation. But whose expectation are we even talking about? Because it turns out, quality looks really different depending on who you are. For you, the customer, quality is pretty straightforward. You're asking, does this thing do what I need it to do? And is it a good value for what I paid? It's a practical, user-based point of view. But for the manufacturer, it's a completely different game. They're looking at a blueprint and asking, does this perfectly match our design specs, and are there any defects? For them, quality is about conformance. Both of these views are totally valid, and they have to exist at the same time.
So how do you bridge that gap between the customer's feeling and the manufacturer's spec sheet? Well, you break it down into smaller pieces. A Harvard professor came up with this brilliant framework for doing just that, the 8 dimensions of quality. It's like a toolkit for making this fuzzy concept totally tangible.
And here they are. Think of it as a checklist for good. You've got performance, that's the main job. How bright is the screen? Then you have features, the cool extras like a power-saving mode. Reliability, does it work the same way every single time? Conformance, does it meet safety standards? Durability, how long is this thing going to last? Service, what happens when it breaks? Aesthetics, how does it look and feel? And finally, reputation, the trust that brand is built. A company has to choose which of these to really focus on. It's why a company like Apple might pour everything into aesthetics and reputation, while a company like Toyota is laser-focused on reliability and durability.
Now, this deep level of thinking didn't just appear out of nowhere. The way we manage quality has this really fascinating history. It's evolved from a really simple idea into the complex, data-driven science it is today.
It all started out super basic. Back in the Industrial Revolution, quality just meant you had people at the end of the assembly line checking for obvious mistakes. But then, a huge shift happened in the 1920s at Bell Labs. They started using statistics to actually control the process as it was happening. After World War II, an American named W. Edwards Deming took these ideas to Japan, and it completely transformed their entire manufacturing industry. That thinking grew into what we now call total quality management in the 80s. Then in the 90s, the ISO standards gave everyone a common language for quality. And today, it's all about using the internet and massive amounts of data to track everything in real time.
Which brings us to a really important question. With all these complex systems in history, who in a company is actually on the hook for quality? Is it one person's job? Is there a quality department that handles everything?
The modern answer is, well, it's pretty much everyone. It's a whole chain of responsibility. It actually starts with marketing, whose job is to figure out what customers want in the first place. Then design engineering has to turn those wants into concrete technical specs.
Procurement has to buy the right parts. Production has to build the thing correctly. And it doesn't even stop there. After the sale, the service department is still part of the quality chain, fixing problems and feeding that info back to the designers.
And hey, this isn't just some abstract textbook theory. If you go and look at a real-world job posting for a quality assurance officer, like this one right here, you see this exact chain of responsibility in action. These are the folks who keep that whole chain linked together. Look at what their job is. They handle customer feedback. That's the user perspective we talked about. They manage the company's quality management system and make sure it's compliant with ISO standards. That's the manufacturing perspective. They're the ones developing the processes to make sure quality is baked in from the very beginning. They really are the engine that makes all this theory actually work in the real world. And that brings us to our final thought for today. We've traced quality all the way from a gut feeling to a hard definition to a system managed by a whole team of people. But as we saw in that timeline, technology is always changing the game. So I'll leave you with this question to chew on. In a world of AI, big data, then automation, what is the relationship between a computer and quality control? What happens next? That's a story for another time. Thanks for joining me.